I've been following background for some time. But so today we'll have three different presenters. Kayleigh Houde is an associate principal and the global computational projects lead at Buro Happold. Kayleigh is the chair of the MEP 2040 commitment and a lecturer at University of Pennsylvania's Weitzman School of Architecture. Joel Ahern-Ray is materials specialist with Turner Construction, and he leads material science and low carbon materials initiatives for the company's national engineering group. His work focuses on practical strategies for decarbonizing construction materials, with an emphasis on supplier engagement, embodied carbon education, and field-ready solutions. And Scott Farbman will be joining us partway through the hour, and he is an architect by training with 15 years of practice experience in high performance building design, but has recently pivoted into a new position as senior manager on the policy and ratings team at Energy Solutions. So with that, I'll hand it over to you, Kayleigh, to get started.
Thank you, Laura. Let me just share my screen. Is everyone able to see my screen?
Yep.
Okay, cool. It was hard to tell which screen I'm sharing. So we will be speaking a bit about two current initiatives at MEP 2040. For those of you who are not familiar with MEP 2040, we were, I guess, born out of the desire for MEP to be advocated for as a big contributor to both operational energy and embodied carbon, as well as fugitive emissions in the built environment, and wanting to have some specific advocacy around that. CLF actually was our kind of host for the first number of years. We now are fiscally under Architecture 2030. But MEP 2040 has had a lot of great participation in its data analysis and reporting group over the last few years, since we were incepted in 2021. And two of those major initiatives that were born out of the DAR group, as we lovingly call it, are first, the Beginner's Guide to MEP Embodied Carbon. This is going to be published in just a couple of weeks, getting final edits in right now with CLF. We're co-publishing between MEP 2040 and CLF. And this is just full of all of the things that we've all been wanting, or at least I have as an MEP engineer, in terms of those really specific pieces of guidance you need around how to perform takeoffs properly, all that fun stuff, which I'll talk to you about here. And then we also launched the Whole Life Carbon pilot. That was launched February 5th of this year, and that will go through July of this year, where we're walking through the guide a week at a time in terms of how to perform takeoffs initially, how to perform A4 through C analysis, how to perform uncertainty analysis, and then compiling those results together for lots of different building topologies. But the goal here really is to find that sweet spot of whole life carbon trade-offs in MEP, because it is complex. Any of you who studied building science at all know that the passive envelope has a lot to do with how the MEP systems perform. And that's somewhere we want to get to understand how you make the best choices for all reasons in the decarbonization space. So that's where we are right now with those two initiatives. So to give you a preview of the Beginner's Guide to MEP Embodied Carbon, what this looks like I said, the big piece that was missing here, I work for global practice, and I see lots of reporting that goes out to bodies like Greater London Authority, where they require MEP embodied carbon as part of their reporting. And I look at the numbers, I'm like, that's not right. I don't care if you have a passive system. Those numbers don't feel right to me, knowing the amount of MEP content you have in terms of ducts and pipes and wiring and conduit and cable tray and mechanical equipment, electrical equipment, PV, right? All of those things take up embodied carbon on day one. Not only that, but they get replaced very, very often. So making sure that we're spreading that knowledge from an engineer practitioner standpoint to say, here's what you might see modeled, here's what might be missing, and here's what we should definitely measure, and here's exactly how you do those measurements in BIM, giving really precise, here's the formula you put into your schedule to make sure that you can get the right mass total for all of your piping of different types. So the takeoff section in the A1 to A3 upfront embodied carbon is almost solely focused around how to kind of parse through those different systems and making sure you're taking account of everything you should be, and purposefully leaving out some of those smaller items because we don't have enough EPDs to support them today. Also, we think that it's kind of the 80-20 rule. Let's not inundate everyone with all of the little parts and pieces of MEP. So we left off a lot of the kind of like receptacles and air terminals and things like that because they tend to be proportional in quantity. So that's the takeoff portion. Then we transition into A4 through C guidance. And you might be saying, Kayleigh, 240p is being developed. Why do we need this? Well, 240p, with the best intentions in the world, tended to leave out quite a lot of MEP scope that we felt was really important. So making sure that we were giving that MEP practitioner lens of, here are all of the categories that we said you should measure. Now, here are all of the values that we think are associated with them for transport impacts, construction impacts, well, waste at least, starting to look at the actual construction emissions associated with drilling geothermal wells, things like that have to matter, right? If we started to measure it, we could effectively reduce it in the future, hopefully. So taking a really kind of deep dive into what those impacts mean for MEP systems specifically. We looked at refrigerant emissions. Of course, those are important, but making sure that we were adhering to either 240p or RICS or CIBS-ETM 65 North America where possible. So using the values from 240 around refrigerant emissions at installation, annual, and then end of life. Looking at the maintenance and repair impacts, we worked together with a few manufacturing partners to get some preliminary values against what we believed those to be, rather than taking the 10% rule from RICS. And then moving into replacements. How often are systems actually replaced? Using the lifespan data from 240p in that case against all of the categories that we thought mattered, filling the gaps in again. Operational emissions, obviously very well developed. So I think we've been reducing for a very long time, but making sure that we were using the same grid factors as they prescribe in 240p, looking at water, including that and the operational impacts, and then also looking at end of life and what realistically is happening. And that was something we worked really closely with Joel and Turner on. What is the recycling rate of all these MEP component parts? We can't just assume that it's 90% like a lot of these categories may default to in tools that you're using or in other guidance, really taking a close look at the MEP specifics of that. We also looked closely at uncertainty. If you know anything about MEP, it's usually just, there's not enough EPDs. We couldn't possibly measure anything. We actually found many EPDs. However, some of them were not as technology specific as we would have liked. A great example here is the pump we ended up using was like a 3 kilogram pump or something. We tend to have pumps that weigh closer to like 500 kilograms. So that's not a great EPD to use, but it's what we have. So uncertainty is a great space for us to really shed some light on how you perform those calculations and what that adds up to within a case study. So we also had a very in-depth case study that we performed on University of Illinois Urbana-Champaign's Weimer Hall. So going through the discrete results that we were able to find within Weimer Hall. And then finally, some calls to action that we had that Joel will be going through a bit more specifically. So like I said, in the kind of takeoff arena, what does this look like? Covering the many categories. You can kind of see the table of contents there for this section, making sure that we were giving that specific advice, that we gave a workflow actually for how you would do this more generally and what to do when you encounter those either data sparse categories, like sprinkler piping is not modeled in half of the country, so you may not find branch piping, or what do you do if you're at schematic design? Please don't try to measure MEP systems. They're way too scarce in terms of modeled entities at that point. Wait until LOD 200, but really spelling that out for people because you may not know it if you're not an MEP engineer who's used to practicing kind of BIM. So giving that advice up front, and then, like I said, giving some kind of general takeoff advice. Material defaults were really important. So if you're not an MEP engineer, you may not know that domestic water is generally copper piping. Some of these kind of material defaults that you would find, obviously defer to your project specific guidance, but in the absence of that, knowing what materials are used for what systems at what sizes, there's a bit of nuance there. So making sure we were embedding all of that, and then giving that Revit specific takeoff process. And then finally, some embodied carbon default values that we were able to find. So making sure that we were showing that kind of breadth of all of the different materials you may end up using on a project, and then what the embodied carbon looks like for those pieces of piping at different sizes, just so that we could give a spread of information there. Moving into the A4 through C and uncertainty categories, like I mentioned, we wanted to give those kind of really in-depth tables associated with just MEP categories, and then giving the uncertainty breakdown of how exactly that works in RICS at present. But what does this look like for us in terms of MEP products? We end up doing that as part of the uncertainty calculation for the project, the case study that we were doing, but really trying to give a kind of best advice at this point. And we hope that there's more information in the future and that those uncertainty values are not quite as necessary when we have lots of product-based EPDs that are US specific. Within Weimer Hall, this is where things became really interesting for us. Is Scott actually on right now? Cool.
I don't see him. I think he said he wasn't going to be free till 12:30. So I think you're good to run through the case study.
All right, perfect. So with this case study, Weimer Hall, so Scott was with DBHMS, and they very graciously volunteered this project. The university signed off on our use of this project because they had done a great deal of work on making sure that this project was, I think it platinum. I may be speaking out of turn there, but I believe that that's what they were going for in terms of a certification, and understanding what it would be that would move the needle for not only the MEP systems to reduce their embodied carbon, or what actually changes whether or not an MEP system would have that embodied carbon number go up or down, but also what does the envelope look like? What does the structural system look like? Because those passive impacts have an effect on MEP systems. And knowing how to define this building functionally so that we could compare it to other buildings in the future. That's where our pilot program was born out of, and saying one project is not enough to define the number around MEP embodied carbon content. It may be one of the first very in-depth studies that's done, but we need more data. We need to make sure that we're covering not only universities or campus systems, we need to cover data centers, airports, residential, office, laboratories, right? We know implicitly as an MEP engineer, you would kind of say, I could generally tell you the swing in terms of EUI from lowest to highest of all those projects, but we don't know the discrete quantities around fugitive emissions or embodied carbon for them. So defining those important characteristics, like what is the topology for the building, which we just went through, what climate zone is it in? It's funny because as a part of the CLF V2 study, Brad Benke was speaking to me, and he was like, climate zone actually doesn't have an impact on the embodied carbon at all from what we've pulled together. And I said, you didn't pull MEP system information into there. It matters. Of course it matters. It matters operationally, and then it matters in terms of the amount of system equipment that you end up putting in. We know that by gut feel, we don't know it for sure yet based on these results, but that's something we're hoping to find out. So climate zone is a super important part of our functional criteria at a building level. Also making sure that we knew the envelope design. What U values were you employing there? How many stories above grade was this? If you go above, I don't know, something around like 25 stories, got a lot of pressure in the building, you'll need to add a secondary mechanical room. So things like that matter for MEP systems, as well as defining some of those characteristics around the cooling capacity, heating capacity of the systems. If you had branch sprinkler piping, if you have radiant floor piping, if you have underfloor systems, all of those will move the needle for us in terms of MEP content in the buildings. We also wanted to provide quantity takeoff information just to be really transparent about the quantities we were dealing with on this project. So giving that in terms of specific line items that we evaluated on the project up front. It was about 400,000 kilograms of MEP stuff in the building on day one. So making sure that we have that kind of laid out before we start presenting the results. On day one, so the A1 to A3, and this is, well, not day one, ahead of that, no A4, A5. But just looking at the product impacts here, the MEP system came out 128 kg CO2 per meter squared. For every MEP embodied carbon assessment I've ever done, and not even necessarily by these rules, the number tends to come out around 120 for some reason, in my experience. But a lot of those numbers that are touted across industry are around 60 for MEP or 50 for MEP. And I'm like, what are you measuring that's the number? Because even in the case of being connected to something like a campus central loop for chilled water or heating hot water or steam, the numbers are still coming out that way. So I think there's even more embodied carbon to be discovered for MEP. But that number is much higher than you would have initially heard in industry, where the structure was around 250, enclosure was 95. So we're looking at about a 25% contribution by MEP on day one. Now, the enclosure and the structure, they just stay pretty static for the 60-year life of a building. That's not the case for MEP systems, though. You see on the right side that that number rose from 27% to 52% when just considering the embodied impacts, so replaced systems, fugitive emissions, things like that. And it rose to 73% when you consider operational energy. That is also with a very optimistic picture heading toward 2050 and the operational emissions from the grid in this area. It's near zero when you reach 2050 is when the grid is at zero. So that's the number that's contributed from there on. I think it's like 25 from that point and beyond. So being careful just in terms of thinking about how we're positioning that overall. But you can see the contribution from MEP is enormous. And that's something we should certainly be paying attention to across the industry. Joel?
Yeah, so kind of the MEP facet now lines up where we kind of need more data on a lot of fronts, and that's a lot of the takeaways from both the study and the reason the pilot has now unfolded since February. So one piece that was outlined in this calls to action section highlighted the study from LMN Architects comparing the number of EPDs typically in a whole building LCA, where structure has around 5 that were used, envelope was around 15, interiors hovered around 50, which is a large number, but for this study found MEP exceeded that number, where over 60 plus. So it is a large amount of work and EPDs that are needed to get a true understanding of the impact of these systems. But I mean, because of the, like Kayleigh showed, 76% for the Weimer Hall case study, there's a major impact in the data. It needs to be collected and better understood. But because it's still a nuanced EPG generation for the industry, there's a lot of product gaps. So for most equipment, we had difficulty finding appropriate representations in the EPD. Kayleigh mentioned the pump example, where we were scaling from a 3 kilogram pump to 500 kilogram pumps that were used in the system. So that's just one example, but there's a lot of equipment outside of chillers where EPDs are lacking. So that includes conduit, cable tray, different piping, ductwork, and then into some of the equipment like pumps, terminal units, air terminals, boilers, heat exchangers. There's a lot that we still need from manufacturers on that front to get more product specific type 3 EPDs, third party verified. As far as the calls to action, so outside of the major EPD gap, Kayleigh touched on it a bit, but there's a lot of focus on what's happening at the end of life with this equipment or these materials. So not only designing for disassembly, making sure that these pieces of equipment can get recycled and turned back into the supply chain more easily. integrating take-back programs for a lot of these manufacturers would be a huge step, and then designing for durability, so extending the lifespan of the equipment. So you have maybe one or two fewer changeovers of these equipment pieces during the life of a building would greatly impact as well. For the design community, requesting EPD, so driving the demand from the manufacturers by asking for EPDs or LCAs, or no matter the stage of the project. I know Turner's had success where by the time that the equipment is on site, we need an EPD, maybe not when the bids are put out, but by asking for a delayed time period, you can then push the manufacturers to get that process going. And then implementing embodied carbon requirements, specifying disposal procedures like we talked about. So a better understanding of what's happening at the end of the life, not just for the equipment, but for the building as well. And then working with the entire supply chain. So the manufacturers, contractors, and then also facility managers who have a major impact on how these MEP systems function during the life. And then for owners outside of just general education, a lot of it is setting emissions goals. And then a big piece for MEP is also refrigerant leakage. So Kayleigh touched on fugitive emissions. This is still a understudied impact as far as how much refrigerant really is leaking. As one of the origins of the DAR group, I believe, was to track fugitive refrigerant emissions. So we still need better data collection on that front, and that's another one of the calls to action. As far as the actual roadmap to 2040, so starting with product category rules, these are pretty well developed in structure and enclosure, but we still need more granularity from MEP specific product category rules. And then EPDs are a major focus, but we need more technology specific, manufacturer specific, geographic, specific, where a lot of the EPDs we used for the Weimer Hall case study and what's available now are European examples. So they might have even more optimistic grid factors than what we have available in North America. So we need more North America specific EPDs, specifically on the MEP front. And then from there, the whole life carbon benchmarking. So Kayleigh touched on the number of factors that influence, especially MEP whole life carbon. And all of these are a part of the benchmarking effort for this pilot project. So not only building typology, which has a major impact on how much piping or ductwork or mechanical equipment is needed, you have the climate zone, and then also even just better understanding how much of an impact the envelope has on the specified MEP systems and how much we can drive the whole life carbon picture by increasing the efficiency of the envelope will be a really cool and hopefully impactful piece of this pilot as we continue to gather more benchmarking data there. Then from there, once we get these baselines, hopefully that'll give us enough to inform the CLF baselines and add the MEP materials into the Carbon Leadership Forum biannual materials baselines. Hopefully for the next edition, if not certainly for the following one. And then once we have all this data, it'll only help build out this data set and help the entire industry make better decisions and more informed decisions on what are the drivers of MEP whole life carbon and how that affects the entire carbon footprint of a building for that entire lifespan. And then from there, once we have the data, we can improve upon it and make more intentional and long-lasting decisions in that regard. So here is the breakdown of the project typologies for the aforementioned whole life carbon pilot. So we have a pretty good variety of projects as a part of this effort. Education is leading the way at 9 here, but we do luckily have 3 transportation hubs, which I think was not expected when we started the effort. 3 labs, hospitals, and then some of the other smaller typologies represented include residential, warehouse, data center, and then a hotel and a museum as well. So what are we looking for from the design community? in relation to MEP 2040. So like we talked about, there's a number of factors that maybe weren't as or seen as important for the whole life carbon picture that MEP 2040 throws a wrench in. So by defining those project criteria like climate zone, the number of stories and building type, we're going to see a great fluctuation in MEP 2040. And so we have to include that as part of the data calculation and framing the projects appropriately. Like I mentioned previously, and like we've talked about, advocating for the efficient passive envelopes. We don't exactly know how big of an impact or what the scale of impact will be, but we do know that there will be an impact of improving the envelope. And it's exciting to see what the impact will be and how much we'll be able to downsize equipment and what the whole life carbon impacts of those more stringent envelopes are. But it's still yet to be seen, and we're hoping to gather more data on the pilot project there, or the pilot study there. And then also, like Kayleigh mentioned, we do need, at least for MEP, an LOD of at least 200 for modeling for the MEP designers in order for us to really get enough granular data to make measurement possible, to do the MEP takeoff calculations and doing the material quantities there. And hopefully out of this collaboration, we'll be able to include interiors in the full scope, and a similar study could be taken on from the interiors perspective, because like MEP interiors, the interiors of a building are turned over many times over the whole life, unlike the structure or the enclosure. So major impacts are still yet to be fully understood in that way. So hopefully that's an extension and future steps for a similar guide.
Thanks so much. I think Scott will be joining soon, but we could start to field some questions. I know Jeremy and I can we already have a few lined up, so go ahead, Jeremy.
Well, I was actually gonna open it and just give everyone else a minute in case anyone had a question they wanted to ask before I jumped in. The answer can be no for now. And if you think of one, please raise your hand. Or just jump in. This isn't a huge group. So one question I have, and there may not be a good answer to this yet, but how, I guess, like, what is a good assumption we can make now for impact of MEP systems, and how generalizable is that number? I know, Kayleigh, you were saying that you typically see numbers kind of falling into the 120 kilograms per square meter like bucket in a rough sense, but is that I know it's not going to be consistent, but relatively consistent across geographies, across system types, and all of these other things, or is it something that really needs to be understood at a finer level of detail?
It's definitely something we need to do more studying of in this discrete way. If we all have the same methodology for measurement, then I think we can maybe come out with some of these. Generally, the piping for an MEP system that has XYZ components is this number. Before that time, it would be reckless of us to start providing numbers like that, right? So something like your sprinkler piping, probably very consistent among things that have the same hazard class. So that's something that if you were designing a fire protection system, you would look at the hazard type. That would determine how many sprinkler heads, how much branching you needed to have. That's the type of like informed answer that we would have around something as simple as just the sprinkler piping. That way, when half of the country doesn't actually model it, we can make that kind of fill in the gap or take it out completely, like making that choice of whether we include that in if we think it can be decarbonized in any way. So starting to think about that's the longer term journey we'd like to go on. But when you start talking about if it's got ground source heat pumps, or if it's got, cooling towers or chillers, or it's 50-story building, 25-story building, 80-story building, you're looking at very different numbers potentially. And that's just like a gut feel. We think that those are going to be pretty different, but you don't know until you're in there. And I think we don't know a lot of those answers yet. There's a lot of difference in terms of methodology of measuring. Did you only model every 5th floor if you're in a residential building? If you're in an airport, you don't model any of the fit out spaces. How do we functionally define these types of buildings to say, don't measure your fit out space, assume that it's this amount, or model one, like what, we don't even know what those questions are yet. And the pilot group's actually been really enlightening because we're kind of seeing those questions creep out from people of, I'm designing a laboratory. Do I measure all of my kind of systems associated with the lab, the specialty equipment? Probably not at this stage, but we don't know. We don't know yet. And I think those are the things we're dying to find out. We're really excited to have those as part of the pilot program, but would never put a blanket number on any of these figures at this point because we just don't know.
Yeah.
So I have sort of a general question, which is that when we talk about structural embodied carbon, the takeaways are that to reduce it, you can either optimize through design, like don't have transfers, try to make your sizing match the actual loads instead of copy pasting up and down the building. And then there's the second approach, which is, make the materials better with lower embodied carbon. So cement replacement, blah, blah, blah. So for MEP, like, is there an equivalent kind of conversation happening, which is about like, let's make these ducts out of either alternative or better materials, or materials that have more recycled content, or materials made from, better, factories with clean energy. That's one thing. But also on the design optimization side, sometimes these systems are oversized just because of, habit, code, or safety factor. Is there any conversation about that to address the actual size of things and trying to look at it through embodied carbon lens and maybe optimize there?
There are so many answers to that question potentially. We could probably all take turns in this. I mean, around, if you think about safety factors for MEP equipment, you tend to have N+1 on your larger equipment so that you can maintain the other piece of equipment and the whole system doesn't go down. It's probably a lot of embodied carbon that just for, 6 hours, 12 hours. Can we as a human race get more comfortable with being a little uncomfortable for a little while? Those kinds of questions of how should we handle that? Does that actually have a large impact on the embodied carbon? Again, we're not sure yet, but we'll get there soon because we're starting to measure at least like what are the masses of things. A giant heat exchanger initially when Aurora Jensen was doing the get, she was like, heat exchanger is so small. Why are you including in this category? And I was like, they could be massive. It's lots and lots and lots of metal. That's not something we should, just throw at projects with that kind of mentality of having extra pieces of equipment, ostensibly. We don't know yet. I don't know if Joel, Scott, you want to add in reduction opportunities for MEP seem to be.
Yeah, I mean, Laura, you mentioned some, I guess, low-hanging fruit of, increasing, there's so much metal between ductwork and pipes and mechanical equipment. So they're asking for higher recycled content is a relatively easy way to lower the embodied carbon of those pieces, subject to availability of certain metals. So some are more easily recycled, and especially domestically than others. So there's some limitations there as far as what is available, but that's a relatively easy one, at least to ask for and advocate for. And then there is the shift with refrigerants, moving to lower GWP refrigerants and understanding what true leakage rates are. I think we've had members of the group advocate taking a critical look at VRF systems just because there is a greater tendency to leak from those systems due to the complexity of piping and the additional refrigerant piping. So that's maybe one I think we need to have a better understanding of, but I think there's a general consensus from the industry that there's likely a positive impact if we moved away from VRF systems. Those are kind of the two ones I point to whenever I get asked this question, as someone who's not an MEP engineer myself. So
one area to add that is if any of you know, hi everyone, sorry for being late. If you know Stet Sanborn from Smith Group, he's very much into thermal storage and promoting the potential of downsizing your equipment in combination of thermal storage systems, which is just like a bunch of water, right? Or
Yeah,
whatever it ends up being. So I think that there could be some interesting conversations with your engineers around the potential of doing that. And I don't know what climate zones he's promoting those kind of new system combinations in. I think California stuff, so it might be different. And maybe Kayleigh can jump in here, but it could be different for a New York climate zone. But it could be something also interesting to learn more about, ask about, speak about, etc.
for sure. Josh, question.
Hi, y'all. Good morning. Can you guys hear me okay?
Yep.
Yeah, great. Awesome. Super great work. Thanks everybody at CLF for putting this together. I've got two questions about sourcing of GWP data and EPDs. So I'm on EC3 actually right now, and at the moment they have two MEP-esque, I'll call it. They've got conveying equipment, which I think is elevators, and then network infrastructure. Do we know if EC3 has plans to include MEP, EPDs in the future, or what's like, is there a, sort of like the best in class one-stop shop currently for this, or what would be the recommendation for sourcing?
It's a fair question. So with EC3, if you're on any of the pilot versions, you'll see that they've started fleshing out some of the MEP categories on
Okay.
the left side, like you'll see them there. However, with few PCRs, there's little definition of the functional equivalence of different pieces of MEP equipment, right? So I think
Right.
things like the capacity and the weight and all of those factors that we would take into account, all the different component parts of something like an air handling unit, there's a lot entailed there that their system would be great at, like making that functional equivalence characteristic for us at a product level, but that definition is not quite there yet. So I think that that is kind of evolving as we get things like PCRs. Also, the development of EPDs in the US for MEP equipment is so poor. It's so poor. If you go into EC3, you'll find lots of like pipe insulations from Knopf, Owens Corning, Johns Manville. Like there's a lot of EPDs in that space, but we've struggled with using US based tools for this work. We have a state of tools page actually as part of the guide, and that describes where, you know, where does Tally sit with this issue? And I'm actively in conversation with Ryan Welch from Tally and Vaslav from EC3 about how we can kind of make this transition to including MEP and what does that entail. So we're optimistic about where that will go, but I think it's, again, we don't want this to be a chicken and egg problem of like the EPDs have to come first and then you do this later. One nice tool that we've found in the space is OneClick has an MEP carbon tool. It's different from something like the Tracy tool that they have because it's breaking the rules of just using that methodology. It's bringing in CML related EPDs. So you get the full range of global MEP EPDs that are out there. I think Schneider just added like 17,000 EPDs. I might be wrong on that number. It might be higher. So they have, I think, over 100,000 different EPDs. They're not all fit for purpose. Like you go and look for a transformer and I'm looking through them and my electrical colleagues like, Kayleigh, think about what that's for a telephone pole. That's not for a building. Like, because that's not my frame of reference being, I'm not from an electrical background. So there are a lot of red herrings in there. So knowing which EPDs to choose is a bit of a struggle. But once you have that baseline set down that we all worked through as a DAR group and were able to use the case study for, branching out's a little bit easier to find something a bit more specific, but we're really certainty to kind of bridge those gaps in geography, temporal specificity, if it was relevant technologically. So a lot to take into account, but at least there's a repository of all of the EPDs that we would potentially lean on.
Okay, great. That's awesome. That's very good information. The sort of second follow-up question I have, I think, has been discussed in various formats, and I'm wondering if maybe the guide also speaks to this a little bit, but counseling clients, so developers and owners, on the value of creating EPDs, because at the moment it's very much like a chicken and egg kind of situation. So we were discussing with the client recently about like whether to include MEP in their LCA, and their main concern was just the availability of EPD data. But like, if clients, on the other hand, if clients don't ask for this, the vendors aren't going to create it on their own. So like, we have to start creating this sort of like feedback loop of communication. So I'm just curious, like, if there's any sort of guidance as to like how we can counsel owners to say like, this is the value of going through the process and spending whatever it is, $16,000, $20,000, at least for like the distribution. The value of the process of like creating LCA and EPDs for the organization versus just relying on like whatever data is out there.
That's one where we actually had a forum on this. I think it was the 11th quarterly forum. If you go onto our website, where we had large owners come to that forum
Awesome.
and manufacturers who they were partnering with to say, if you want to put your equipment on our rooftops, you need to have an EPD. And
Yes.
we know the facility is not going to be built for 2 years, so you have enough time. So making sure that that relationship between the owners and the manufacturers is set up well, because that pressure works, right? If you say, you know that I have a very large data center being built, and I want you to be my chiller manufacturer. If you have an EPD, you'll get people who are actually given that kind of incentive monetarily to push those along. And I think a lot of that has to do with the spec language that you're writing. And I know that WAP has been working closely with owners to even just get that spec language down. We do have some samples on the website of sample spec language that you can include. On MEP2040.org. So I think that pressure, like you're saying, it has to come from the owner side, and then the manufacturer has to respond, but it takes time, right? EPDs don't happen overnight, but establishing that relationship with the finance department and all of those things, once you get the ball rolling there, it's made much, much easier for every other EPD you create thereafter.
Is there any, or this could be an idea of a CLF New York kind of working group to coordinate with maybe like the NYSERDAs of the world to start putting some of these embodied carbon items on NYSERDA's radar so that they can develop potential programs to incentivize manufacturers to make EPDs, at least in like the New York state. I don't know what is being manufactured in New York and if that is a good or helpful thing, but I know that's happening in some other states, and it could be a good idea to look into here.
Where's it happening, Scott?
Well, in terms of working groups, so right now in California, there's a lot of activity because Cal Green is up for a new cycle, and there are embodied carbon requirements in Cal Green, so that AIA California and CLF like LA and the other CLF city working groups have come together to try and submit comments and recommendations and move the needle there a bit in California. And then I know in Massachusetts, the Mass CEC had a pretty good grant program. It was specific to concrete mix though, where they were giving money out to concrete mix manufacturers to get EPDs done because they determined that to be the lowest hanging fruit in Mass. And then just a little inside baseball. I love using sports references because I'm not a sports person like at all. So it's funny whenever I do that. But I'm active in the NYSERDA stretch code development process, and I've kind of floated some embodied carbon ideas there, but it didn't gain a lot of traction. So I wonder if it comes from more external grassrootsy type groups and organizations. They might have an appetite to start looking at that stuff. And then you're kind of creating, in a sense, you'll create that demand or necessity for EPDs to be done.
Yeah, I mean, New York State, I think, is in a place where there's some embodied carbon legislation. It tends to be focused on like infrastructural materials like concrete and steel, not so much requiring LCAs yet. So for the MEP stuff, it feels like it's going to be a longer game. But it would be good to know though, like who's ahead already just based on like the information you have now, just as a factor of where the factory is located, what kind of grid is it plugged into, just so that like architects can specify or have like a sense of like relative values among the different manufacturers, if that's known.
Yeah, and you know, and sorry, this goes beyond just MEP specific stuff, but it's been front of mind. But to get that kind of market transformation, it could require kind of incentive type programs, or it requires policy, and then those two things just kind of like continue to cycle on each other, the incentives and the policy and the codes and standards. But I think something really cool that Massachusetts is doing is they put embodied carbon measures into the commercial C406 table. So that's the additional efficiencies table where you have to like meet the base code and then you got to do a couple extra things. And they've wedged embodied carbon in there as an additional efficiency measure to start essentially give these projects credit for doing low embodied carbon work, and then B, get the ball rolling more collectively across, you know, the industry and that specific state. So I think there's really cool opportunities popping up in policy and standards like elsewhere across, which could be gleaned from and maybe kind of used to, because New York is progressive, right? Like there is a lot of great code development work that's already happening. I think with the right structure and combination of folks contributing, embodied carbon could be put on the radar there.
Cool, great. Any other questions? I have more, but I want to let other people speak. Jeremy, anything else on your, yeah, go
Well,
for it.
I was actually gonna, Scott, give you an opportunity if you wanted in this lull, if you had anything specific to present, you could take a few minutes, or we can kind of keep going with the Q&A. I just wanted to offer that up.
Kayleigh and Joel covered what I was responsible for, and thank you for doing that. So yeah, I think keep Q&A rolling. Let's have the conversation.
So I had a question about geography, because I know all sorts of different materials, the EPD location matters differently, right? Concrete is hyper-local, but cement isn't. Steel is semi-local unless you're in a port, and then it's not necessarily so local. Carpet is from who knows where, everywhere, usually Georgia. So for MEP systems, like I understand that you're using European EPDs at the moment for things. How far should we be looking? Like, is it, you know, do we need to be looking? I don't think it's New York specific necessarily, but maybe for some things, is it North America? Is it kind of, we just need more EPDs from other places globally?
Well, it depends where you're speccing from, right? So sometimes you'll meet a mechanical engineer who's like, Grundfos pumps have never failed me in my life, and that's the only pump that I ever want on projects. Mechanical engineers tend to be very specific. Or you might say, I know it's going to come from this Bell and Gossett factory over here, not that one over there. So I think it does depend on that kind of supplier relationship that you have, where Grundfos pumps come from Europe anyway. So that might be the product that you're specifying very far away that has that big A4 impact because you're traveling it over here. Same thing for like glass on buildings. It has to come from Italy because it's a special green color that has to be in this building. So, and you know that ends up having a massive A4 impact. With MEP products, again, it does depend what exactly you're specifying, who you're specifying from, if it tends to be local, but again, supply chains are long and things may come from lots of different places in terms of where the raw materials came from. The finished products may happen in parts and then it's all assembled together. So I think the provenance around MEP components tends to be really complicated. And I think you get a feel for that in the A4 tables where you're kind of seeing like solar panels and batteries tend to be made in Asia, where we're kind of giving that preliminary split of where we believe things are coming from, but really they as component parts could be coming from anywhere. Or if you're talking about ductwork and pipes, they're probably coming from more local places. But again, depends where you are when we say local. It's a toss-up, but I would say every category is different, but the engineers are sure to have opinions about where things would come from or able to give you kind of approximate locations. I don't know, Joel, if you have anything from a kind of construction point of view in terms of where things might come from an MEP side.
Yeah, I guess like just to add on to that, when we're part of the guidance was to look at where the equipment's specified or looking to be specified from, and getting as close to both the product and geographic location and matching that up as best as can. Again, because of the limited information that's available, you're going to have to make some jumps in either conversions or where you're getting that EPD from, and then that goes back into the uncertainty piece as far as trying to match the grid factors. If you're getting an EPD from Europe that meant where you're actually the equipment on site is actually being manufactured in Arkansas, or so there is going to be some uncertainty, but it's essentially making a best case effort to best match the products that are a part of like the project that you're modeling, and then talking with the affiliated parties who are specifying those equipment, or even the manufacturers is where you can get it from.
Yeah, this is super interesting. I'm gonna try to squeeze in one more question. So MEP equipment is this interesting intersection of embodied and operational carbon performance. How has your experience like developing this study been received among the engineering community? And do you predict that is it mechanical engineers who are going to be taking up the cause, or is it going to be something added to like a sustainability consultant's job to analyze the model stuff? Like, I'm just kind of asking a meta question, like, how do you see the process of optimizing, reducing embodied carbon working out in the design phase of a project, if that's been discussed at all?
I think it remains to be seen a bit, but if we think about kind of typecasting our industry, I guess it would help a little bit, because I think in terms of the way that the guide presents itself, it gives MEP engineers a great way to kind of say, our BIM models are set up in this weird and wonderful way across the industry. We need to have these kind of cornerstones of how we do takeoffs from them. You can set that up in your templates that you use on every project to make whoever's life easier when they're actually performing that takeoff. You also know all of the nuance of your systems in terms of what is modeled, what is not modeled. In the case of Scott's project, there were 70 geothermal wells that are 450 feet deep with no piping modeled. That would be an alarm bell in my head as a mechanical engineer in terms of you're potentially missing a lot of scope here if you go to do a piping takeoff, where someone who's an LCA practitioner may have no idea that that's missing and just do a blind takeoff. I think it's this intersection of the technical specificity and knowledge of your project engineers, and then where you would be performing the takeoff and knowing which EPDs to specify, which materials to assume. You need to have that communication flow back and forth, the same way that you would with energy modeling, right? You don't make assumptions without speaking to the engineering team. Or maybe you do, I don't know. But I think that you need to have that tight relationship in order to reduce the passive envelope, see what the impacts are in the MEP systems, right? It's a back and forth. And I think that hopefully we'll get to a place where we're able to optimize in a really bespoke way with this kind of general guidance that we'll be able to distill out of all of these studies, but it's going to take time. Scott, do you have thoughts?
Yeah, I've got a couple. I just want to second that it is 100% going to be a collaborative, integrated kind of process to get this done. Even when it does become mainstream, as Kayleigh mentioned, with energy modeling, that already is. It's still very much a collaborative process across disciplines. I think we're at an interesting point in time where we've got stuff from like LEED v5 coming down the pipeline that will require you to do some level of prereq integrated process carbon thinking, and those are probably like start to use that as an opportunity to discuss some of these things with your consultants and disciplines, across disciplines or whatever it is. I really think that's going to be a great kind of nudge in the right direction. I know we're still a little ways out from that becoming, required in the LEED world, but there's nothing that says we can't start like incorporating that framework today, and getting people ready for it. And I know back when I was at the MEP engineering firm, when we would propose system design options to the architect and the owner and the team, we would have tables that kind of compare a couple different systems, and it would have rows for, like first cost and ongoing maintenance and operational energy performance. And there's no reason that carbon couldn't be included in that table, but I think it does need to be asked for, probably, to be considered. And operational carbon would be pretty easy to do, but embodied carbon, I think you can start asking for these things and just get the conversation going.
Yeah, fantastic. I think that's a good note to end on. We're just at the beginning of a whole new era, I think. MEP embodied carbon transparency. So I wanted to thank all three of you for joining us today, and everyone else who joined, thank you. We are looking forward to the report coming out soon. So we'll share some information with the group about that later. Oh, and sign up for MEP 2040. Yes, I'm going to spread the word. Great. Thanks, everybody. Have a good day.
Thanks, everyone.
Thank you. Bye.